Hello everyone, let's look at question number 56. Prove that root 5 is an irrational number. Let's prove this by taking the contradiction of this statement. That is, we have to assume that root 5 is a rational number. We can write root 5 is equal to P by Q because we have taken root 5 as a rational number. So it can be expressed in the form of P by Q, where P and Q should be integers and P and Q are co-prime. We have to select P and Q in such a way that they are co-prime. Okay. So if we take the square of this equation, we will get root 5 square is equal to P by Q whole square, which will be equal to 5 is equal to P square by Q square, because here root and square will be cancelled. So 5 is equal to P square and Q square. So if we rewrite this equation, we will get P square is equal to 5Q square. We are cross multiplying here. So P square is equal to 5Q square is the equation we get. If you look at this equation, P square is equal to 5 into some number Q square. So 5 is one of the factors of P square and Q square is another factor. Together, their product will be factors of, their product will be equal to P square. So these are the factors of P square. So we can say 5 can divide P square. If 5 can divide P square, then 5 can also divide, therefore 5 can divide P. If a number divides square of an integer, then it can also divide that integer, correct? So 5 can also divide P here. That is, P can be written as 5 into some number. These are the factors of P, correct? So let's assume this number as A, then it will be 5A. P is equal to 5A. So let's substitute this value in this equation 2. Let's call it as equation 2. Substitute the value of P in equation 2. So we will get 5A square is equal to 5Q square. 5 square is 25 and A square is equal to 5Q square. Let's rewrite this for Q square. 25A square divided by 5. 5 ones are 5 fives are. So Q square is equal to 5A square. See, this is the equation we get and it is very similar to this equation, correct? So we can say Q square is the product of 5 and some number A square. So both 5 and A square are factors of Q square. So 5 can divide Q square. Therefore, 5 can also divide Q. So 5 is the common factor of both P and Q. Because 5 can divide P and the same 5 can divide Q. So it will become a common factor for both P and Q. But we have assumed root 5 a rational number and it is expressed in the form of P by Q where P and Q are co-prime. The numbers are said to be co-prime if they have 1 as their common factor. Only 1 can be their common factor. But here we got 5 as the common factor of P and Q, which clearly indicates that both P and Q are not co-prime. So our assumption is not true, which means whatever the assumption we have taken is wrong. So the statement given is correct. Therefore, P and Q are not co-prime. This implies our assumption is not true. Therefore, root 5 cannot be a rational number. So it should be an irrational number. So root 5 is an irrational number. Okay. This is how we prove the statement.